Hello, everyone. A very happy evening to all the students here, to all the +2 students here. So yes, I'm really happy to introduce today's program on behalf of Amrita Vishwavidyapitham. So it's the refresher course, which is actually aimed to help you with those topics which you feel tough in your subjects that you're studying in the school. So this is a 7-day continuous program, and you'll have session from evening 6 to 7. And students, kindly note that all your queries related to the topic will be addressed by our faculty. And faculties from different campuses of Amrita will be conducting these sessions. All of them are experts in that particular area. So yes, without further delay, I welcome you all to today's session, the day 1 of refresher course. So today the topic is of mathematics, and it is definite integral. And today's speaker of the session is Dr. Murali Krishna sir, and he is an assistant professor of senior grade in the Department of Mathematics, School of Physical Sciences at our Coimbatore campus, the University campus of Amrita Vishwavidyapitham. So yes, coming to just give you an idea about who is Murali Krishna sir. So his background is like he has completed his BSc in Mathematics, Statistics, and Computer Science. He holds an MSc in Mathematics, and he has completed his PhD in Mathematics from NIT Warangal. So yes, he has been with Amrita for so long, and he holds the position of a faculty who is dealing with the PhD students, guiding them in their projects and all of them. And his interested areas are applied mathematics and computational modeling. So yes, really happy to welcome you, sir, towards today's session. And I'm also excited because it's going to be an interactive session. And I know as of now, because there are a lot of students in the session, I have not given permission for you to speak. So students, kindly note in between, if you're having any doubts or anything related to the formulas or the problems or anything, what you can do is you can just type that in the chat box. So our faculty will be just discussing that once he receives the query from your side. And towards then, you may ask for the tips or any doubts that you have related to the topic. So over to you, sir. Now, yes. Thank you.
Thank you, ma'am. And welcome, students, everyone, for today's session on definite integrals. Am I audible?
Yes, sir. You're the audio video is completely fine. I think you can just share the screen. I'll just stop sharing.
Ma'am, can you tell me the status? Is the screen
yes,
shared?
Sir, it's completely fine. It's shared, sir. You can continue. Thank you.
Good evening, students. And today our topic of discussion is definite integrals. And everyone of you, I think you are a little bit nervous in answering the questions of integrals, especially. And this topic, we came to know this is one of the most tough topic for the students of +2. Okay, anyway, we will discuss today, and I'll try to clear all your doubts. And before having a discussion, I just brief you what is a definite integrals, how a problem can be solved. Just brief introduction about, and then we go for question and answer discussion. See, everyone knows notation. Hope you can see the screen, and
yes, sir, it's visible.
Please observe this. This is the usual notation of writing definite integral, whereas the letters A, B, if there is no letters of A, B, we can identify that integration problem or integration doing of a function as a just like it's not a definite integral, indefinite integral we will call. So here integral a to b f of x dx means you are doing the integration of f of x within the limits of x equal to a and x equal to b. And geometrical meaning of this thing is like it indicates an area of the graph of the function f of x and x-axis between the limits of x equal to a and x equal to b. This is geometrical meaning, and as a part of applications of integration, you will do the problems of like finding areas and all using definite integral concept. But as a beginning here, we try to learn how to do this type of problems. So mostly the questions are like integrable, like this integration is exist, the answer exists. Some questions, there are some questions we need to take care that some definite integrals cannot exist. So which problem exists, which problem do not exist, like that theory comes as a, when you come to graduation, you will learn. But right now, you are like, you can pre-assume that all problems of what you are going to solve have answer, and no problem is a like no problem is not having answer. Like that way, such a situation won't be there. Anyway, here everyone know the definite in the definite integration. If you do integration, just simply integral f of x dx, and our answer is capital F of x. I hope I will write here. One second. Integral f of x dx is equal to capital F of x. Then this capital F of x is called antiderivative of this small f of x. We will call this as a antiderivative of small f of x. And this, once you know this answer, then if it is definite integral a to b, then this answer is nothing but we will write symbols as a, b, and the final answer is capital F of b minus capital F of a. So this is a simple manner we compute the definite integral. So once you know the integration, basic integration answer, and the answer is capital F of x, and we substitute the capital, this upper limit, and here a is called lower limit of the definite integral, b is called upper limit of the definite integral, and these values a, b are substituted in the antiderivative function. So that's why here antiderivative, you can see the word antiderivative f. And we finally, we write the definite integral answer as f of b minus f of a. This is a simple way we compute the answer of a definite integral. And as I told you, this is a application. So to find the area, like this is, if you take a graph of this function f of x, and this is, let us assume this is a graph, and between the limits, lower limit is x equal to a, and upper limit is x equal to b, then this notation, integral a to b f of x dx, this answer, whatever, after doing the problem, you will get a number. Say, indirectly, simple example is integral 1 to 2 x dx problem. If you take, everyone know y equal to x graph. Everyone know, I think everyone of you know y equal to x graph. This is a y equal to x graph. That means this is a function y equal to x function, nothing but x function. Between x equal to 1 to x equal to 2, this area answer, the region bounded by the x graph and x-axis and the limits x equal to 1 to x equal to 2. Please know, observe here, the shaded region is what our answer. Actually, how this answer is equal to our answer. If you notice the shape of this area, like this is a one square where this is a point height 1, and at the line x equal to 1, here x equal to 1, x equal to 2, and there is a triangle also. Please notice there is a triangle also with the height of another height. And hope you can see this area of the triangle, the area of the square is one square unit, because this height is 1, length is 1, breadth is 1, and this base value, this base length is 1, height is also 1. Height is also 1. So this triangle area is half into base into h. So this is equal to half. Total area is this triangle area plus this square area. So together we can say 1 plus half is equal to 3 by 2 square units, we can say. So simple measurement of simple way we can understand this integral 1 to 2 x dx answer is 3 by 2. But this is by means of areas. But once you do direct integration as a regular manner, you can notice here x square by 2 is the integration. Integral x dx is x square by 2. under the limits of 1 to 2 we will write. And this is equal to, upon substituting upper limit, 2 square by 2, which is 4 by 2, minus lower limit is 1, which is 1 by 2. So nothing but 2 minus 1 by 2. So 2 minus 1 by 2 also 3 by 2. Please notice here, this answer and this answer both are same. It is indirectly nothing but this graph area. That is what the application of this definite integral we use in the area computation. Now, anyway, today our topic is how to do definite integrals with for a different kind of problems. Now, let us go from basic topic to properties using properties of definite integral. Use of properties by using properties and basic rules. We try to learn some problems. Now, so the rule of how to compute, as already I told you, if antiderivative is f of x, look at this formula. So this is the way we write the expression. Integral a to b f of x dx, answer is capital F of x. A capital F of x is nothing but the answer of the integration. The answer of the integration within the limits of a to b. And that is equal to this function value, like we will substitute the upper limit at capital F in capital F minus we'll substitute the lower limit in capital F. That means capital F of b minus capital F of a. So that is the way we will compute. And finally, you'll get the final answer as f of b minus f of a is the answer. So let me go through some simple examples as given in the textbook of your CBSE syllabus. So first question here, you can notice everyone can see this. I think this thing. I think integral 2 to 3 x square dx. So the first question answer is simple. Hope everyone can know the integration formula of x square is x cube by 3 under the limits of 2 to 3. So this answer, this x cube by 3 is our capital F of x. So substituting the upper limit 3 in the place of x. So with respect to what variable you are doing the integration in, only we will substitute the upper limit. In the place of x, substitute the number 3 cube by 3 minus 2 cube by 3. So once you simplify, this is 1 3 can cancel, 3 square, which is 9. And this is 8 by 3. So ultimately, if you simplify, 27 minus 8, 19 by 3. This is the first question. Anything you want to ask for this first question?
No, sir. I think as of now, there are no queries.
Okay. Second question, let us go. Similarly, second question. This is second question, integral 4 to 9. Integral 4 to 9 square root of x by 30 minus x power 3 by 2 dx. Now, please notice here, this is somewhat complicated problem. If you treat it, remove this, leaving somebody raise hand, go pick up. Any objection? You can type the.
Yes, students, if you're having any queries, please do make use of this box. I could see.
Start a question and answer. You can.
Yeah, in both the places, you can just type it. Okay, she is actually saying it's question wrong.
Oh, the question is wrong. I took it from textbook, ma'am.
Okay. No,
Okay.
no. I think what she is mentioning is in the denominator, you have missed a square. 30 minus x raised to 3 by 2 whole square. Yeah,
correct.
that's what
I'm about to write.
yeah, okay.
So please look at here, this expression, like this problem comes under substitution method as x power 3 by 2. If you do derivative, 3 by 2 into x power 1 by 2 will come. If you take the term separately, x power 3 by 2 alone, then derivative of this term, like 3 by 2 times of x power 3 by 2 minus 1 will give you 3 by 2 times of x power 1 by 2, which is root x. So this is a simple understanding where this problem is under the category of substitution method. So you can take this entire expression as a some t. So for this question, you can take this as a some t equal to 30 minus x power 3 by 2 and your dt. dt is equal to minus 3 by 2 times of x power 1 by 2 into dx. So I'm sorry, dt is equal to, so this root x dx answer is minus 2 by 3. 2 will come this side, 3 will come to down, minus 2 by 3 dt. So this entire numerator, please notice here that is entire numerator root x into dx can be expressed as minus 2 by 3 times of dt. So our problem, integration problem, will be converts to integral minus 2 by 3 times of dt by e square. So finally, this answer is minus 2 by 3 times of t power minus 2 integration is t power minus 2 plus 1 by minus 2 plus 1. So this is equal to, and this is minus 1, you can cancel it. And ultimately 2 by 3 times of 1 by t. So this is equal to 2 by 3 times of 1 by t. T means, come substitute back once again. 30 minus x power 3 by 2 under the limits of our original limits, please substitute 4 to 9. So 2 by 3 times of 1 by 30 minus 9, if you substitute, this is 3 square, which is 3 cube. 3 square power 3 by 2 is 3. 3 square and by 2 will get cancelled and 3 cube will be balanced. So 3 cube minus 1 by 30 minus 4, if you substitute 2 square, which is 2 cube. 1 by 30 minus 2 cube. So final answer is 2 by 3 times of 1 by 30 minus 27, 3 cube, which is 3, minus 1 by 30 minus 8, 22. So this is a number you can simplify further. So whatever answer it comes, like that way. In the similar way, you can just this question, I can able to tell you this question comes under the concept of partial fractions. So everyone of you know x by x plus 1 into x plus 2, you need to go for a by x plus 1 plus b by x plus 2 category, and ab you are supposed to find, and then after doing the integration, then you can substitute. Similarly, this question also, sin cube 2t into cos 2t. See, you can understand this question also under the method of substitution. Here you see, if you assume sin 2t as t, its derivative is something times of cos 2t. Sin 2t derivative is 2 cos 2t dt is a derivative. So this part alone, everything will go under the substitution variable. So that this problems also comes under that category. I will show you the answer for this question also.
Sir, sorry to interrupt, just a second. There are some questions. It's like for this type of question, how we will know which one to take as T?
Yeah, I will tell.
Yeah, that is a question.
See, as I told you in this previous thing, you need to have some basics of differentiation and integration formulas, especially when this substitution method category, some function derivative is also present in the either numerator or denominator somewhere. Say in the second question, you can notice for x power 3 by 2 term, derivative is 3 by 2, as I showed it here. Please observe. For x power 3 by 2 term, in this x power 3 by 2 term is present. If you do this term derivative, root x dx is coming. So just simply root x will come, x power 1 by 2 will come, so that once we take it as t equal to that x power 3 by 2 or entire thing, because this is just a constant number, there is no much difference. Either you take this term alone or this full term alone, that's not a big deal. So if you take entirely, if you do derivative, this term constant derivative is 0. So that dt is equal to this negative times of that what I wrote here, minus 3 by 2 times of x power 1 by 2 dx we will write. So this x power 1 by 2 dx is a part of your numerator. Similarly, in this question, sine 2t whole cube. Sine cube 2t means sine 2t whole cube into cos 2t. This is the way you need to understand. So cos 2t dt is there. So if you just remember what is the derivative of sine 2t, something 2 times of cos 2t is the derivative of sine 2t. But here that term is present here. Please notice. So that you need to take in this question t or u equal to sine t. It's some new variable because the question is given in terms of t. Let us take u or x or whatever we want to. 1 second, just give him second time. So I'll erase some portion.
Sir, one more thing. 5 to 6 students have asked about why we have not changed the limit.
I will come to that point.
Okay. Sir, actually, we are recording the session. So if you want, you can clear the whole screen and we can do the next question.
Ma'am, I could not get you.
No, we are recording the session. So we'll be providing this whole session detail to the kids. So if you want, you can just erase and then you can continue also.
Okay, it's okay. I'm trying to take some space. That's what. So this here, substitution method, we will take it as like x is equal to sine 2t. So dx will be 2 cos 2t dt. So this is a part of your integration. So the entire problem will be converted to integral x cube in terms of x letter, sine 2t whole cube, which is x cube, into you need to draw the what is dt term, cos 2t dt. From this you can write as cos 2t dt is equal to dx by 2. So into dx by 2. That is the way. And as you asked, why I am not substituting the limits? Like there are two methods. It is there in this slide. Please look at the slide. Evaluation of double integral, definite integral by substitution method. There are two methods. One thing is get the antiderivative first by regular methodology, then convert to the original variable. See, in the previous question, I in the solution of the example number 2, I did this problem by means of substitution method and I brought the final answer again in terms of the original variable. And that in that answer, I am substituting the upper limit minus lower limit. That is the one way. Whereas another alternative technique is that while changing the variables itself, you can substitute the limits. So for that, this is one example I am trying to show you. Integral minus 1 to 1, sum 5x power 4 into square root of x power 5 plus 1. So please notice here very clearly for the x power 5 term, x power 4 is a derivative. And to dx will go for under the transformation. So let us take this x power 5 plus 1 as a t as given here. Then dt will be 5x power 4 dx is the answer. And after doing like simple taking without limits, integral 5x power 4 into this answer is equal to integral root t dt in terms of t. In terms of t, this is the answer. So this is nothing but t power 1 by 2. T power 1 by 2 answer is t power 3 by 2 by 3 by 2. So once you simplify the denominator fraction, it comes as a 2 by 3 into t power 3 by 2. And this is the finally again convert in terms of the original variable, which is x power 5 plus 1. X power 5 plus 1 power 3 by 2. Then in this answer, you substitute original limits minus 1 and 1. So our problem is integral minus 1 to 1. This original problem answer is equal to this antiderivative in terms of x. Original problem also in terms of x. And antiderivative also in terms of x. And this antiderivative at minus 1 to plus 1. This is what these are the limits. And as per the formula, we substitute the upper limit, which is 1 power 5 plus 1 minus lower limit. And simplification gave this much answer. Okay. Alternative method. What you learned, I think, some of you. Alternative, once you choose this substitution, t equal to x power 5 plus 1, then itself, you can change the limits. So as a part of dt, 5x power 4 dx will come. And we are having two limits. Please notice, we are having, in this situation, we are having two limits. So you need to find here, the new variable is t, variable is x. So we are having x values as a minus 1 to plus 1. And what about the new values? Once you change everything in terms of t, how to get the values of t? From this relation, we will find it out. When x is equal to minus 1 whole power 5 plus 1 is your t answer. Please notice here, minus 1, when x equal to minus 1, that's what written here. When x equal to minus 1, t is 0. So how this is coming? Minus 1 whole power 5 is minus 1 plus 1. Answer is 0. T is 0. And when x is plus 1, 1 power 5 plus 1 plus 1, which is 2. So our problem is converted to integral 0 to 2 root t dt. So whichever method is comfortable to you, you can follow. Both are correct. You may lengthier. You may feel somewhat lengthier. And again, substitution back. If you feel this is a lengthier method, you can follow the second. Nothing wrong. All are correct. See, fundamentally, you need to follow the rules. That following the rules will lead to you the final answer in even it takes some little more time. So any manner, whichever is comfortable to you, you can follow. I answered your question related to why can't we substitute the limits. And see this question again, substitution method, integral 0 to 1, tan inverse x by 1 plus x square dx. I think everyone know derivative of tan inverse x is 1 by 1 plus x square. So that 1 by 1 plus x square is appearing. So I hope you understood what you are supposed to take as the substitution variable. So t equal to tan inverse x, if you take, the dt answer is 1 by 1 plus x square dx is a dt. So here 1 by 1 plus x square x is a dt. So this integration converts to integral t dt, simple. Integral t dt. And they found the limits based on this limits finding. Immediately they found the limits also. And the new limits are, please notice here, when x is 0, what is the value of t? So tan inverse 0. Tan inverse 0 is 0. So that means when x is 0, t is 0. And x is 1, upper limit is 1. So what is t? So tan inverse 1, which is pi by 4. T equal to pi by 4. So thus, as x varies from 0 to 1, t varies from 0 to pi by 4. So the original problem converts to 0 to pi by 4 t dt. So nothing but, and this is answer actually here is equal to missing. This is equal to t dt. Integration is t square by 2 under the limits of 0 to pi by 4. And upon substituting the upper limit minus lower limit, you take 1 by 2 outside, only t square only you concentrate. So t square pi by 4 substitution under t, pi square by 16 minus 0 square. That is the 0. So ultimately this answer is pi square by 32. I will see the question and answers related to. Venkatesh asked, explain the second step. Okay, we will see this discussion by end. And let me go through the next topic. And properties, students, all of you, please remember these properties. Basically, one property is a alternate modification of the another properties. Every one of you, I think, if you change the limits, the integration answer will be negative. I think that is a fundamental property. And what is the first property speaks about? I will brief you what is these properties. In definite integrals, most of the problems are based on one of these properties, or just simply doing the integration and substituting the limits. Either of these concepts only, like our problem will depend. And basically, like under definite integral concept means mostly a problem related to even function and odd function. That problem may be possible, or that may be some problems will be under the category of you need to split the integration. Based on the nature of the function, you need to split the integration in the definite integrals. That is one category of the problem. So that is nothing but the property 2. Like this is a property 2 based on the splitting. We need to do some kind of problems, some category of problems. And once you see this thing, first property, what it speaks that the variable of integration is dummy. The variable of integration is dummy. That means integral a to b f of x dx or integral a to b f of t dt. Both are same. Both are same. As you know, simple integration, integral 0 to 1 x dx answer, if we take, this answer is x square by 2 under limits of 0 to 1. If you put 1 by 2 minus 0, which answer is 1 by 2. Instead of x dx, you take y dy. Y dy. Under the same limits, change the variable only, nothing else. So this answer is y square by 2 under the limits of 0 to 1, means upper limit minus lower limit, again 1 by 2. See, finally, the number what you are getting is same. This letter is dummy. This letter is dummy. Don't, please remember this. This letter of integration. So integral f of x dx and within some limits a to b, and integral a to b f of y dy, or f of a dA, f of t dt. All these letters are like variable of integration we will call. And these variables are dummy in definite integration. Finally, the answer is a number. So it represents the area of this graph. And second property, once you change the order of the limits, second property speaks, once you change the order of the limits, integral a to b f of x dx, and if you change the order of the limits means make the upper limit as a lower limit as upper limit. In the answer, there is a change with respect to the minus. Like minus will come. Integral minus of the b to a f of x dx. This, hope you experience this thing. In particularly, and this is the meaning. And this in particular, integral a to a, if upper limit and lower limit is same, a to a, f of x dx is 0. So simple. If you do integration, let us assume this antiderivative is coming. And upper limit is a, lower limit is a. F of capital A minus f of capital A, answer is 0. So if limits are same, then the answer of the definite integral is 0. And property number 3, please notice this property number 3 is a P2 rule. Second, you need to understand in the definite integration, there is a real line where there is a lower limit x equal to a, x equal to b. Upper limit is a bigger number and smaller number. And in between, if you take any number, you can split the integration from here to here and here to here. That whole integration from A to B can be splitted as a part of any number of integrals. If you take just one middle point, this A to C, C to B, A to C and C to B. Or if you want to take 2 points, C1 and C2, then the answer is integral A to C1, C1 to C2, C2 to B. Any of like any manner you can do. It is just like for some cases you need to follow this. For some category of problems you need to apply this split up of the interval of the integration, or split up of the lower limit and upper limit. So for what function this property you need to apply, I will tell you. I'll tell you. This is another property. Integral A to B f of x dx, meaning is that this is same as integral A to B f of a plus b minus x dx. So what is this meaning is that I think till now we are discussion like what is a alternative or geometrical meaning of this. Our definite integration is, say this is a graph of f of x under the limits a to b. Let us assume this is our graph, and that this area bounded by this zone is the left side. This is the left side. What about this right side? Right side is nothing but under the limits of like x equal to a, x equal to b. Please observe here, if you put in this function, if you put a in the place of x, you will get f of b. That means at a, the function is changed as f of b. Instead of f of a, the function is changed as f of b. That means this much height brought at a. And if you substitute b here, this is a f of a. At b, it is f of a. Nothing but this graph is reversed. The same interval length is same. Instead of taking this style, you take this style. This style you take. Just like a mirror image. Flip it with respect to the midpoint. You make some 180 degrees turn. So if you flip, this peak will come to left side, this lower bottom will come to right side. So like that way, this graph will be converted to in this style. And ultimately, this area and this area both are same. That is what the meaning. This P3 meaning is graphs only interchanged. So this is, I think, major application of some major problems are coming in your CBSE exams. I think I saw some sample papers. If you understand P3, how this is coming, you can memorize what, like enter the graph. This is also here enter the graph, but this graph is different. This graph is different. What is the difference is that we flipped the graph. Simply, am I audible, ma'am?
Yes, sir. Yes, sir. It's completely fine.
This is a flipped graph. And you can notice P4 property. The place of A, put 0. In the place of B, take the number A. 0 to A, f of x dx. So, like for specific number, lower limit is 0, upper limit is some positive number, A. So, for that case, A plus 0 minus x, which is A minus x, you can write. And this is the thing, 0 to 2A, f of x dx is equal to, this P5 is 0 to 2A, midpoint is A is there. So this full 0 to A integration doing is bringing into 0 to A only. Please notice here 0 to A. Both limits are 0 to A. So within half interval only we are doing. But what about this A to 2A problem? A to 2A problem is shifted. This graph also taken in this zone. So that is possible. This is something we will transfer this graph, original graph entirely like this way. So this problem originally taken as it is the first case, this one. What about the second thing is 2A minus x is like this was shifted again in this zone, with respect to the substitution method. So this property holds good for any A value. And this property also speaks about even function and odd function concept. So I will brief you P6 after telling you P7. P7 is that once our function is even function, and our graph is even. Please look at this thing. Even function means it's under the limits of minus a to plus a. So instead of doing entire interval, you can do only half interval. 2 times of integral 0 to a. Under the case of, please see, this is the shape of even function usually. F of minus x and f of plus x both have same heights. That's what the definition of f of even function. So that the graph, the total area will be two times of half of the zone. So this is what for f of x, and the same thing instead of minus a to a, if the limits are from 0 to 2a, 0 to 2a, this is the definition of even function with respect to the line x equal to a. So in between this line is 0 to 2a, midpoint is x equal to a. So the same definition of f of a function is even function with respect to 0. With respect to 0 is f of 0 minus x is equal to f of 0 plus x. With respect to a point a is f of 2a minus x equal to f of x, and f of 2a minus x equal to minus f of x, then we will treat this as a like even function and odd function definition with respect to the line x equal to a. So that's way this P6 property will be used. Rarely this we use. Mostly we can understand this limits are from minus a to means you need to use the property number 7 in our problems. And majorly in major problems, we will go for either P7. Most of the problems are based on P7 and P4, sometimes P3. And very rare case, this P5 also will use. And the basic rules of like P1, P2 split up of integrations. This depends on the problem and depends on the question we will apply. And in some cases, like if it is required only, then we'll use. And I will show you some examples in which category of problems they are falling. Please see, already these answers are there. I just brief you shortly. Evaluate this integration, -1 to 1. I think you need to understand what is this modulus of x cube minus x. Modulus, where whenever in definite integrals, modulus property comes means, you please remember this function inside will be negative in what zone, positive in what zone. That split up you need to identify. So from -1 to 2, you can think of integers, especially -1 to 0, 0 to 1, and 1 and 2. 1 and 2. This way you can split up, or actually under what zone your x cube minus x is greater than or equal to 0. Say this is positive under what zone that we want to identify. So actually mod x definition is that x for x greater than or equal to 0 minus x for x less than 0. This is a mod x definition. So now here our integrand is modulus of x cube minus x. So this is equal to, as per modulus expansion definition, that extended definition, which is equal to x cube minus x for this entire term, x cube minus x greater than or equal to 0. And this is negative of x cube minus x for this x cube minus x less than 0. So you need to find under for what x values this is positive, for what x value this is negative. If you find that, then you can split this integration. So for that, if you just start this expression, you can split like x into x square minus 1 greater than or equal to 0. Now please understand, it is a product of 3 terms, x into x minus 1 into x plus 1. X into x minus 1 into x plus 1 greater than or equal to 0. So there are possibilities like x positive or x negative. So if x is positive number in our zone, up to 2 positive numbers are there in our interval of integration, or under the limits -1 to 2, positive numbers are from 0 to 2, negative numbers are from -1 to 0. So in those zones, what is the nature of f of x, or your nature? If you see, you can understand very clearly. So this description is that one. X cube minus x is greater than or equal to 0 in the interval of -1, 0, and less than 0 in the interval of 0 to 1, and it is again greater than 0 in the interval of 1 to 2. So based on these nature, so once it is greater than 0, mod x equal to that same x. So that's why this from -1 to 0, x cube minus x, this modulus is x, like cleared. Modulus, after clear definition, we are writing. Once inside term is positive, we'll write as it is. Inside term negative means minus of that quantity. So this x cube minus x is negative in the 0 to 1. So for 0 to 1 zone, our function is, modulus function is negative of that thing. And for -1 to 0, it is positive. So as it is, we will take. Again, from 1 to 2, it is positive. So that means x cube minus x as it is, you can take. So after splitting this category, you need to do regular integration. That is what. So this problem, whenever you see modulus, observe the inside term and in what zones it is positive, in what zones it is negative. You need to monitor that. Please remember this point. Minus pi by 4 to plus pi by 4. See, hope you can understand integral minus a to a category problem. Whenever you see integral minus a to a category, it may be under prop P7. Under the P7 axioms, even function and odd function, there is a scope for using of this topic. Okay, minus a to a, c, if you see the limits, think of this property. So sin x is odd function. So sin x, sin square x is the sin x into sin x. So it's an even function. This you can write it as 2 times of integral 0 to pi by 4 sin square x. And again, regular integration, converting sin square into in terms of cos 2x, and then simplification, and then substitution. That regular manner. This way. Based on limits, you can identify. And this problem comes under 0 to pi x sin x by 1 plus cos square x problem. I could understand from the textbook that whenever you see the x terms are sin x, cos x terms with 0 to some, 0 to pi by 2, 0 to pi, that type of limits means you can remember that this problems comes under the category of P4. P4 category, P4 property, please look into 0 to a f of x dx is equal to 0 to a f of a minus x dx. This property, which is a general specific version of P3. That property. So that category, I think I could see guaranteed one question is asked in every board exams under that category. So this is, I think that is the logic applying that thing. So here, these questions actually, these questions, whenever you use the P3 or P4, there is a possibility that in the simplification, again, I will be present in some manner. So once you simplify these terms, so here, if you notice, this x is replaced with pi minus x, upper limit minus f of our property is that you need to remember the property integral 0 to a f of x dx. Answer is integral 0 to same limits f of a minus x dx. See, I told you the function is flipped. This is a flipped function. This is a regular function. So this limits you can apply. So that means in the integrand, x will be replaced with pi minus x. Wherever x term appears, replace with pi minus x. Here pi minus x within sine of angle, pi minus x, 1 plus cos square of x place, pi minus x, not x, not at dx. Please remember, only in integrand, not dx term. Integrand only, we will replace. Only f of the place, here f of x is there means here f of a minus x. X is replaced with a minus x. So here a value is pi. So f of pi minus x. That expression we will take and we will simplify. Now, finally, you can notice here, upon shuffling the terms and all, again, this problem is, this answer is equal to pi into sin x by 1 plus cos square x, this one term, minus x into sin x, this is the original problem, x into sin x by 1 plus cos square x, and that problem, they wrote it as I again. So you started with I, which like entire integration, entire definite integral is assumed as I, and again I is present in the simplified version. So you take this minus I to left side, so that will become I plus I 2i. 2i answer is equal to pi times of 0 to pi sin x by 1 plus cos square x dx. So that means I equal to pi by 2 times of this answer. Now, how to do this question answer? Say for this question, they are applying the substitution method, putting cos x equal to t. Cos x equal to t. See, you may be getting it out like how do we know after coming to this stage, we need to do substitution method or some other method. See, it's simple to understand. Say here you landed with an expression which is of this style. Sometimes some questions, what it happens is 2i is equal to some 5. Then from that you can write I equal to 5 by 2. That means instead of this integration, again one more expression, you may land with constant. You may land with a constant. That means I equal to 5 by 2 is the answer you can write directly. Say in these situations where whenever you don't land with any constant, whenever you land with any function or any new integration problem, that integration problem you think of, is this problem can be solved by any of known methods. Suppose this problem also, there are some examples where this problem also in this stage, again you need to apply our P4 again you need to apply P4 or P5 or P6. There are certain examples. Okay, so like multiple times applying, like ultimately we will to ultimate, like finally till what level you need to apply these axioms and all until you reach the final answer as a constant number. You need to think of some ideology or some property. So which property can we apply and all? Just understand like you which property is applicable here. Say here sin x by 1 plus cos square x. So if you assume this 1 plus cos x are just simply cos x equal to t, sin x dx is a dt you can take. So that means there is a scope that dt by 1 plus t square. So dt by 1 plus t square means 1 by 1 plus t square form. So tan inverse x formula. Tan inverse x's derivative is 1 by 1 plus x square. So that conversion, it may be possible. So that's what we need to understand. So this I equal to pi by 2 times of, and this after conversion, these limits are changed to 1 to -1, the minus symbol. Again, with using this minus symbol, they put in a proper manner, -1 to 1, dt by 1 plus t square. So pi by 2 times of tan inverse x or tan inverse t under the limits of -1 to 1, or that is same as 2 times of under, because the limits are -1 to 1, 2 times of 0 to 1 you can write. Why? Because of this function is even function. So please any property, either you do directly -1 to 1 or that property using, ultimately we landed with pi square by 4. Next, this is also some simple example under the concept of limits are -1 to 1. So that question may be falling under the category of even and odd case. So just identify whether function is even and odd. This basic knowledge is required for doing this type of problems. Even function example, cos x is even, sin x is odd. Even into odd is odd, even into even is even, odd into odd is even. These property you remember. So here sin power 5, sin x, this is a sin is multiplied 5 times. odd number of times. Odd number of times odd function is odd. Again, cos is multiplied even number of times even. Ultimately, odd into even is odd. So this answer is 0. Simple. Because odd function, we will say this is 0. Similarly, this question examples, you can see sin power 4x by sin power 4x. See, luckily, this is a under property P4. Replace x with pi by 2 minus x. And you see a new expression is coming. I answer. This is a original problem, and original problem answer is same as another problem. So that means this is also I. This is also I. So original problem converted to another expression where integrand is different. So that means this is also I, this is also I. To get the answer of these two, and if you do sum, sin power 4 plus cos power 4, that is the denominator. Now using these two i's, if you add these two i's, that numerator and denominator will get cancelled. So that is the ideology here in this question. So I plus I, they will take. The first I, they will put this expression. The second I, they will put this expression. So that final answer is like 2i on the left hand side 2i. And this is equal to like numerator by denominator cancels, and this answer is integral dx, simple, which is x under the limits of pi by 2. So this answer is pi by 2. 2a equal to pi by 2 means I equal to pi by 4. That means either this question or this question. Whenever question is asked either this or this, you can understand this is a methodology, and answer is pi by 4. Similarly, I think this is some special problem. How do we get the thought like this? Generally, I can give you one suggestion that tan x, sin x under definite integral coming means think that this is under the property of the P4 property. There is a scope that if you apply P4 property, that question may be solved. But here, this problem is used by P3 because P4 property is a special case of P3 where the lower limit is 0, but here lower limit is not 0. And not only that, pi by 3 plus pi by 6, if you simplify, which is 6, 2 pi plus pi, 3 pi by 6, which is nothing but pi by 2. Sum of these two terms. Actually, f of x is replaced with f of a plus b minus x in the property P3. In our integration of integral a to b, f of x dx is equal to integral a to b f of a plus b minus x dx. This is what our P3. You need to remember these properties. So like that way, you just see this. It is a plus b answer is pi by 2. And tan changing directly in terms of tan pi by 2 minus x, like that way. Instead of that, if you have in terms of sin and cos, it would be easy. That is the reason they converted in terms of sin and cos. And you see, this is if you assume this as the original I, they got another I equal to I, another I. So this is also I, this is also I. And if you add these two i's, numerator and denominator will get cancelled. Same logic like previous problem. So they added 1 and 2. And they got that numerator and denominator cancel, and that is a integral dx under the same limits, which is x between pi by 3 to pi by 6. Final answer is pi by 6. So 2i equal to pi by 6 means I equal to pi by 12. And this also, I think, by looking at the problem, as I told you, sin, cos, these functions appears means think of the property number P4. Okay, so in this question, please notice here, this is a lengthier one. They started with I, and they simplified, they applied the property, and they got a different function, and that function is also a logarithm of cos x. And okay, let us add these two functions. Let us add this I, this I, this I also. So they added 2i, log sin x and log cos x. See, if you do this thing, this based on the property of logarithm, log m plus log n equal to log mn. But I see any common student will land with here this situation, logarithm of sin x into cos x. Very sure you will get stopped here. Logarithm of sin x into like log m plus log n equal to log m plus m into n. Sin x into cos x. Logarithm within logarithm sin x into cos x dx only will be there. And who will get the thought, like nobody will get the idea that we need to add log 2 and minus log 2. So my suggestion is that you remember this is a strategy for this problem. And whenever sin x cos x comes, you cannot do anything. So ultimately, here the logic is that we want some 2 coefficient here. We want 2 sin x cos x is there, means this will become sin 2x. Sin 2x. So to multiply this to get 2 here, they added 2 plus 2, and here they subtracted minus 2. And this log 2 and log of sin x into cos x, that will become log of 2 sin x cos x, that is nothing but log of sin 2x under the limits of pi by 2. And what about this minus log 2? Okay, the same limits 0 to log 2, some constant number that is there. Okay, still answer is, did you get? No. Again, this is a separate problem. Again, this is a separate problem, this first integration. So this is what, like after doing this thing also, you don't land the final answer. So you need to go for any alternative methodology. Now you see the strategy, they changed this tx to 2x to t, and they converted this problem into a new problem. So that problem converted as integral 0 to pi log sin t dt. Please look into this. And again, this problem answer, they applied integral 0 to pi, they applied a rule of, the one rule that, I'll show the rule. Please look into this rule and this P6 rule. If you are doing 0 to 2a f of x dx question, if f of 2a minus x is same as f of x, then you can write this question as integral 0 to a f of x dx. This is what the idea. So here in our question, see upper limit is pi. So 2a equal to pi you are having. This 2a place integral 0 to 2a as a property. 2a equal to pi, f of 2a minus x is equal to f of x, are you getting or not? That you need to verify. That means sine of here, logarithm of sine of pi minus t is same as log sine t. Log sine pi minus t is same as sine t. I think you know that. This is equal to logarithm of sine pi minus t equal to sine t. Because of that property, they are writing this problem as, here 1 by 2 is there, 1 by 2, 2 times of integral 0 to pi by 2. To pi by 2. Again, you need to solve this problem. 2 by 2 will get cancelled. 0 to pi by 2 integral logarithm of sin x dx. Please notice here, our original problem is this one. 0 to pi by 2 logarithm of sin x dx. Again, that expression came here, logarithm of sin t dt. That can be converted in terms of x, and that is nothing but our I. Say 2i is equal to I minus this constant number, pi by 2 log 2. So left side, this you take to left side, 2i minus I. So I is equal to minus pi by 2 times of log 2. See, there is no specific rule of what is the strategy, how do we know this is the way we need to go. Remember, for this type of questions, this is the ideology. I understood from textbook that some questions also similar to this category. But most of the questions will be with simple formulas only, but there will be some tough problems using especially P4, P6 and P3 rules. You need to simplify, apply all the possibilities and simplify such a way that you land with a final answer. Okay, that's what I can say. And thank you from my end. And let me see your questions.
Sorry. So, sir, I think we can just give them permission to talk when they're raising their hand so that we'll be able to help them.
Sure, ma'am, sure.
Okay. So the students, you can start typing your queries in the chat box. I think the question number 34 that sir has already explained. How to find whether the given function is odd or even? A question by Gemini.
Can you ask, ma'am, is she required that answer?
Yes, sir. Yes, sir. That's a question just came now. How to find whether a question is, sorry, given function is even or odd?
You can note it down. In the given expression, replace x with minus x symbol. Replace x with minus x symbol and simplify. Simplify, and if you are getting the final output again as f of x, that is the meaning that f of minus x is equal to, see here, I am writing f of minus x equal to f of x. If this comes, then that is the even function. If you get minus f of x, if you get f of minus x equal to minus f of x, that is the odd function. There are some situations where you don't land anything. So there are some functions which are neither even nor odd. Neither even nor odd. That functions are called, I can say neither even nor odd. So some simple examples I'll tell you. F of x is equal to x square plus 2. So replace f of minus x, x with minus x. This is minus x whole square plus 2. If you simplify this again, x square plus 2 only, which is f of x. This is one example of even function. When it comes to odd function, another here I'll write f of x is equal to plus 1. Or just simply let us take x cube. F of minus x is equal to minus x whole cube. Minus x whole cube. So this is minus of x cube, which is minus f of x. But the same f of x equal to x cube function with another form, x cube plus 1 you take. F of minus x is minus x whole cube plus 1. This you can write as minus x cube plus 1. This is not it's not equal to f of x, or it's not equal to minus f of x. F of x is x cube plus 1. So minus f of x is minus of x cube plus 1. Nothing but minus x cube minus 1 is the minus f of x. Or if it is f of x, to declare x cube plus 1 has to be there. But here you have the expression like minus x cube plus 1. It is not equal to either f of x or minus f of x. So this is one example of neither even nor odd. There are functions neither even nor odd. This is example of odd. This is example of even. And you know, basically you remember cos x is even. Even cos of minus x is equal to cos x because of this reason. And sin x is, sin of x is odd. Why? The reason is sin of minus x is equal to minus sin x. And properties of even and odd, you please remember everyone. Even into even is even. Odd into odd also even. But any other combination, even into odd, odd. Odd into even also odd. Like that. Ma'am, can we go for next question?
Yes, sir. There are students who have asked for, can you please explain property 5 again? Another question is, can you please explain another example of property 4, which contains log and sine?
Another example I did not consider, ma'am, right now. Hope it will take a lot of time to solve any other different problem.
Okay, completely fine, sir. I think you can just explain those properties at least. Property number 4 and property
number 4.
4 and 5, I think. Yeah, both the properties.
Like I told you, this is a flipping function with respect to the given job. That way you remember, and you need to memorize the property. And can we ask the student who asked to explain property number 4, what kind of explanation he want, what doubt he is having? If I know,
Okay,
I
just
can.
a second, sir. I'll just check for them and I'll just give them speak permission also. So the student who has asked property number 4, I think I have just given you permission to talk. Can you please unmute and talk? I think it's Lakshmi. Lakshmi, I have given you permission to talk. I know, Aditya, you're waiting, so just hold on. Yes, Lakshmi, we can hear you.
Yes, ma'am. Good evening, sir.
Good evening.
Sir, actually, I doesn't have a doubt in property, but I have a doubt in how to solve such type of questions by having log and sine.
Log and
Sine.
tan question.
Sir, this I think we can take
I
examples and
I
can tell
remember
you.
there is one question of log and tan, right?
Okay.
I think in sample
Not
paper
the
also
not
I saw
tan. It is sine.
sine,
Yes, sir.
log and sine. Okay, right? This is a question I explained right here, which is the log of sine x.
Sir,
can
that is one another question, but in exercise, there is in textbook one exercise is there, no, sir.
uh,
From there, I want one question to explain how to we can do that one.
can you give me the question? Can you tell the do you have the question right now?
Yes, sir, I have.
Please share. Like speak. I can write it here.
Integral
Hmm.
upper limit is pi by 2,
Okay.
lower limit is 0,
Okay.
2 log sin x minus log sin 2x into dx.
2 log sin x minus log sin 2x.
Yes, sir.
So if you apply property number 4, let us take this as I equal to 0 to pi by 2. What do you get? 2 log sin x term will become sin of pi by 2 minus x. I remember this question. 1 second. I hope this is the answer. Is observe here. We need to write this 2 log integral log sin x plus log sin x minus log sin 2x. How to write? Log 2 sin x cos x dx is equal to integral 0 to pi by 2 log sin x one term plus log sin x second term minus log 2 minus, because this entire term will be split into log 2 plus log sin x plus log cos x. So once you take minus inside, that will become log sin x minus log cos x. Hope this term and one of log sin x will get cancelled. And this question will be integral 0 to pi by 2 sin x minus log of cos x minus log 2. This is the expression, right? Please notice, till now, any doubts?
No, sir.
Now let us apply the property. Once you apply the property integral, and this is our I, integral 0 to pi by 2. This, once you apply logarithm, and in this sine of 90 minus theta will become cos theta, right? Cos of 90 minus theta will become cos of 90 means pi by 2 minus x will become log sin x. Minus log 2, there is no change. Dx. And this is also I. Please notice. I, this is a left side, this above is I, which is simplified version of our question. And this is also I. Now, once you try to add this 2I, this I plus this I. If you add, why I am adding these two is, here minus log x is there, here plus log x is there, here log sin x is there, here minus log sin x is there. All these terms, 4 terms will get cancelled. So that this right side, you will have integral 0 to pi by 2. In this integrand, the first integrand plus second integrand. Please notice here, common term, after cancelling these 4 terms, common term is minus log 2 minus log 2. Minus, you can write it as 2 log 2. 2 log 2 dx. So this minus 2 log 2 is a constant number into integral dx is x under the limits of 0 to pi by 2. And this answer is pi by 2 minus 0, minus 2 log 2 into pi by 2. 2 get cancelled. Minus pi log 2 is the answer. Is the 2i answer? I'm sorry, this is answer for 2i. So therefore, I is equal to minus pi by 2 log 2. Hope you are satisfied, I guess.
Yes, sir. Thank you very much, sir.
Okay, so yes, sir, I also think we have covered a lot of questions. Now, are there any further queries, children? Okay, I think there is one more student, sir. I'll just give them permission to talk. Please, Aditya.
Okay, ma'am.
I have given you permission to talk. Can you please unmute and talk?
Yes, ma'am. Good evening. Good evening, sir.
Good evening.
So, sir, sometimes what happens is they give us a step of a function in integration. So, in that case, what do we have to do in order to solve this question?
Step function.
Yeah.
See, step functions actually it breaks at integers.
Okay.
So obviously you need to split the interval of integration. That limits of the integration must be integers shown.
Okay, sir.
So simple integral part of x under the limits of 0 to 5. So dx, the graph is like this way. 0 to 1, height is 0. 1 to 2, this step. 2 to 3, height is 1 more next step. 3 to 4, height is 3. 4 to 5, height is 4. So here, height of the graph is 0. So indirectly, 0 to 1, integral part of x dx plus 1 to 2 plus integral 2 to 3 plus integral 3 to 4 plus integral 4 to 5. That integration dx you need to take. So it depends on the zone. See, simple. These are like rectangle areas.
Yes, sir.
Height of rectangle, height of 4 and breadth is 1. This is also breadth is 1 and height is 3. Like that way. So that anyway, this is a constant number. Here 0, 1, 2, 3, 4 into the difference is 1, 1, 1 each. So answer is 1 plus 2 plus 3 plus 4. 10 will come under the limits of 0 to 5.
Yes, sir.
Okay.
Yes, sir.
I
Thank you.
hope I clarified you.
Yes, sir. It's clarified. Thank you.
So, yes, I think there are no further queries. I think we have addressed almost all the queries that was there in the chat box. So, one more thing.
Yeah.
Okay. Can you ask sir to explain property 5?
Property 5 is actually combination of this split up this and substitution method, ma'am. Actually, I think whoever asked the students can listen and follow. This property you can memorize in this way. Very rarely we will use. So this is a concept of like converting this property 5 is a instead of 0 to a. Say for example, there is a problem with 0 to pi with
Sir.
some integration. Ma'am.
Okay, I have given you permission to talk the student who has asked this query.
Yes, ma'am.
Yeah, you can talk with sir directly.
Good evening, sir. Can you just please explain me the second term?
This second term.
Yes, sir.
Follow what I'm saying. Say there is a question of 0 to pi, some sine and cos terms are there. Say if the limit is 0 to pi by 2, it can be easily convertible. For example, if the limit is 0 to pi by 2, original question is 0 to pi, but if the limit is pi by 2, you can problem can be solved easily. Then this property will come in the picture of like 0 to a, second limit also, second integration also 0 to a. So this property has a special proof line. We split this original 0 to 2a integration as 0 to a, this left side integration, plus a to 2a. A to 2a, this answer is a to 2a, actually integral 0 to a f of x dx plus integral a to 2a f of x dx. Now, I don't want these limits. I want again 0 to a. So there is a like transformation, substitution method. Replace x with this concept, 2a minus t. You can take x is equal to 2a minus t in this question, in the limits. So this, our problem will be converted to f of 2a minus t dt. Actually, dx is equal to minus dt. And you can notice when x limit is a equal to 2a minus t, from that you can write t equal to 2a minus a. Or from this you can write t equal to 2a minus x. When x is a, t equal to a. When x is 2a, t equal to 0. So this problem will be converted to integral a to 0 f of t into minus dt with the plus symbol. The second problem converts to f of 2a minus t into minus dt. Again, using this minus symbol, you can put the limits in proper manner, which is integral 0 to a f of 2a minus t dt. And I already told you this letter of integration is dummy. You can replace with x. So that's what they wrote in terms of 2a minus x dx. See, this property indirectly, when you are supposed to apply, that you need to remember that if original question having 0 to pi limits, and if the strategy is to do only half of the limit, not full 0 to 2a, instead of 0 to 2a, 0 to a only. And if you convert this form, it may be comfortable. It may be comfortable in getting the answer. Then we apply this property number 5. Observe the property 0 to a, 0 to a. This is what you need to remember. Here function is different. Here function is different. This function is f of 2a minus x. The first time f of x. And this sum of these two answers will be integral 0 to 2a f of x dx. For this property 5, there are no restrictions like even, odd, or any like this if conditions. Property 6 and 7, you can notice if conditions are there. But this is a general property. Hope I clarified you. Any question? Please ask me.
No, sir. Thank you.
Okay, welcome.
Sir, I think we have cleared almost all the queries of the students.
Okay.
And yes, it's already 7:40 also. So yes, students, I hope the session was really useful to you. And I know from the way in which you are discussing things with sir, I know almost all the things are clear. So thank you so much, students, for attending today's session. And thank you so much, sir, for sparing this much time discussing everything in detail with the students. And dear children, we'll be sharing, okay, you want the PPT also? Yes, I'll get it from sir. And you'll receive a mail after all these sessions of refresher courses over, you'll receive a mail with the YouTube uploads of all these sessions. So thank you so much, everyone. Thank you all. Thank you so for joining, and thank you so much for the wonderful session. And thank you so much for the interaction. Thank you, everyone. And please do join tomorrow's session with the same joining link. Tomorrow we have a session from biology. It's transcription and genetic code. So thank you all. Have a good day.